Hi everyone, and welcome back to 2.8. In this video we are going to actually find some inverses of some functions. And then we'll also talk about graphing as well. So let's start off with a function. We'll start off with something a little easier. So 3x minus 2. And first of all, I'm going to ask myself the question, does it really have an inverse? And I might not always know that, so a lot of times I'm just going to go with it. But this is a straight line, slope of 3, y-intercept at negative 2, so it is a function that I do know. So it is 1-to-1, and it will have an inverse. To find the inverse, we go through some steps. So first of all, I'm going to rewrite this f of x, because another name for f of x is simply y. If we remember, f of x is Newton's method and y is the Leibniz method. It's kind of like two different guys who came up with their own way of writing things, and they didn't get along, so we just adopt both. And now what we're going to do is, since the inverses basically undo or switch the roles of our x and y's, we are going to switch x and y. So I'm going to rewrite this as x equals 3y minus 2. And then what we're going to do is solve for y. And sorry about that little mishap there. My cat pushed the arm down. So now I'm going to solve for y, which means I'm going to add 2 to both sides. And then I'm going to divide by 3. Okay. And we can check to see if we did everything correctly. So we can check. Because we can take f of f inverse, and we can take f inverse of f, and we should get the same thing. The last step that I do want to do is rewrite this again, because we want to go back to the notation we've been using. And we will rewrite that as f inverse of x being x plus 2 over 3. Okay? And I'm going to just kind of talk through the checking. So if I substituted and did this one first, that means this piece is going in here for x. So the first thing we're going to do is take this thing right here and multiply by 3. Well, if I multiply by 3, the 3's cancel, and I'd be left with x plus 2, and then we'd be doing minus 2. So the plus 2 and minus 2 would undo each other, and we'd just get that x. If we went the other route, this thing here is going in here. So we're going to have 3x minus 2, then plus 2, which means we're going to get 3x over 3, and the 3's would cancel, and we'd get x. So it does check. I am not going to check every example. In fact, this is the only one that I will do, but you should get in the habit of kind of making sure that it does work. So let's do another one. And let's look at, this one. F of x equals x to the 5th minus 3 all over 2. Okay, again, we're going to rewrite this with a y. Not that you'd have to. It's just a little bit easier to work with than dealing with f of x all the time. Now I'm going to switch my x and y's around. And now I have to solve for y. So the first thing I'm going to do is multiply both sides by 2 to get rid of that fraction, and I'm going to go over here. So I'll come up and go over here. 2x equals y to the 5th minus 3. I need to isolate that y, so add y to both sides. And now we have to undo the 5th power. And when I undo this 5th power, that's going to be a 5th root. And one thing I'm going to mention here is if we had a y squared, And we tried to take square roots of both sides. When we take square roots of both sides of an equation, we have to remember the plus or minus. Hence the reason we would then realize this function is not one-to-one, because we'd have two different answers coming out. But our fifth root, we will only get one. So this is kind of how you can tell if your function did have an inverse or not. So our inverse is this function here, the fifth root of, and make sure you get that whole 2x plus 3 underneath that radical symbol. Okay, let's do one more before I change gears. And let's look at this one. F of x equals to 2x plus 3 all over x minus 1. And here we're going to again start with y equals 2x plus 3 over x minus 1. I almost changed the problem to put a plus in there. Switch my x and y's around. And this one's going to be a little bit more difficult, but we will be able to handle it. I'm going to multiply both sides by that denominator, so I clear my fractions. And while I'm doing it, I'm going to distribute as well. So xy minus x is equal to 2y plus 3. Again, I multiplied both sides by y minus 1. And I distributed. And this is where students tend to stop because they're stuck. So I want to remind you we're solving for y. So we're going to treat everything else as values or something and do what we can. So the process when we have things like this is we always got our variable on one side, everything else on the other. So I'm going to bring this 2y over here, and I'm also going to take this x and I'm going to move it to the other side. So I'm going to subtract 2y to both sides, and I'm adding x. Okay, so I added x to both sides and I subtract 2y from both sides. Now you'll notice I have a y in both of these pieces, which I can factor out. And this idea of grouping and factoring out is not something that should be new to you. It might be a little rusty and a little cobwebby, but it's something you want to keep in that toolbox of yours because it is a tool that we use from time to time. So make sure it's kind of fresh. And now we will divide by that x minus 2. Whoops, that's a 3. And so my inverse function is x plus 3 over x minus 2. Okay. How do we graph an inverse? Well, let's start with a one-to-one function. And I'm just going to do one example because I find that this is the fun part. It's nice and easy. And I'm just going to kind of draw in it, making sure it's one-to-one. So let's say I'll put some points in here. Okay, and we'll make this a little steeper. So go down to, so it's going to kind of go up and then get not so steep. So it starts out steep and gets not so steep. Okay, so I'm going to label these points so we can see what they are. This is 1, 3, 0, 2, negative 1, 1, negative 2, negative 1, and negative 3, negative 3. Okay, and I'm going to get a different color so that we can see them. And so this is my function f. So this is f of x. And I want to remind you that when we're talking about the inverse function, the roles of x and y switch. So that's exactly what we're going to do, is we're going to take these points and we're going to reverse the x and the y. So our negative 3, negative 3, well, that's not very exciting. That's going to stay at negative 3, negative 3. This negative 2, negative 1 is going to become negative 1, negative 2. So I'll put that in here, negative 1, negative 2. This negative 1, 1 is going to become the point 1, negative 1. 0, 2 becomes the point 2, 0. And 1, 3 becomes the point 3, 1. And we can, whoops, connect our dots, and we will see that. If I had drawn this nicely, we could have seen that it does reflect. Along the line y equals x. So if we had that nice y equals x line in here, it is a reflection along that line. So it does flip your x's and y's. And one thing you may also notice is this had a slope of 2. Its inverse does have a slope of 1/2. This had a slope of 1. This will also have a slope of 1. The slopes do get reciprocated, but that may be where that negative 1 idea came from. But I did not ask Newton. He's kind of been gone for a while, so hopefully that part you enjoyed, graphing and inverse. You just switch those x and y's, replot your points, connect the dots. So that's the fun part. These, not as much fun, but they're still doable. So I will see you when we start chapter 3. This does conclude the end of chapter 2 that we're going to cover. So make sure to study and practice what you've been working through. Ask questions when you have them, and I'll see you in chapter 3.